Hello everyone, so welcome back to another episode of our MATHFLEX. So for today we have again this problem wherein we are asked to find the derivative of y is equal to 2 raised to x. So if you will still remember or if you can still recall your differential calculus, so it's a lot easier for us to differentiate a variable raised to a constant. Say what do I mean by that? So if you have like y is equal to x squared. So all you have to do is to apply the power rule, wherein you have y is equal to 2. This exponent will move here, and then just deduct 1 from the exponent. So 2 minus 1, so dy and then dx. So this will be now dy over dx. This will be equal to 2x. So similarly, if you have y is equal to x cubed, so dy over dx is equal to 3. Okay, this will go there, and then 3 minus 1, that is 2. So this is the derivative of y is equal to x cubed. So it's quite easy. But what if you have the other way around, wherein you have a constant raised to a variable? So what will be the derivative of this equation? I think we have a readily available formula on what will be the derivative of a constant raised to a variable. So if I may recall you on that, if you have y is equal to a raised to u, so what will be the derivative of this one? So I think it will be dy is equal to a raised to u ln a, okay, du. I think this is the standard derivative of any function or any equation wherein you have a constant raised to a variable. So our purpose now is on how did we arrive with this formula? Okay, so if you will apply this formula here, so you can easily derive as dy over dx is equal to, okay, just copy this one, so 2 raised to x ln 2. This is the answer for this particular problem. Okay, but what if, the question there is what if you forget this formula? So what's the other solution? How you can get the derivative of this one using also again your basic. So let's try to solve this one and see if we will derive with the same answer. So if I may arrange this one first. Say you have y is equal to 2 raised to x. So if I will take the natural logarithms of both sides, so you'll have ln y is equal to ln 2 raised to x. Okay? So again, you have a property of logarithms where if you have an exponent there, so you can move this one on the other side. So I mean, this can be written as x ln 2. Okay? And then you can simply you can simply apply the derivative. So the derivative of ln y, if you remember, you have 1 over y dy over dx is equal now to, okay, the derivative of this one is product rule. You can apply the product rule wherein you have u dv plus v du. So if you will recall on our previous episode, so that means if x, okay, if this is your u, times the derivative of ln 2, this is constant, so that is 0, plus v ln 2 times the derivative of x, which is equal to 1. So in other words, 1 over y dy over dx is equal now to, so this is 0, so ln 2, okay? But we need to find dy over dx only, so you can cross multiply y there, so dy over dx is equal to y ln 2. But we have to express our answer in terms of x. But then again, you will find y here is equal to 2 raised to x, 2 raised to x. So therefore, dy over dx then is equal to 2 raised to x ln 2. Okay? So again, I think we arrive with the same answer here. So I hope you got the point there. Wherein you don't have to memorize all the derivatives of any function. So if it happens you forget, if it happens that you forget it, so all you have to do is you can go back to your basic. Okay, so I think that's it for now. And again, don't forget to hit that notification bell and share if you can. And of course, subscribe. And don't forget to watch our succeeding videos. Until next time, guys. Bye-bye.